Thank you for joining in. This project is funded by the European Union Horizon program. Our webinar series Lessons Learned is a part of the Circ-uits project and contribute to the dissemination of our 3 years innovation action results. Please enjoy.
Okay, we're going to start off with MacDermid Alpha. We're not actually owning a pilot, but we are represented in various of the pilots, mainly in 1, 2, and 3. A brief overview of the content of today's presentation, materials, technology, and circuits. I want to introduce MacDermid Alpha to you, the evolution of low-temp solder and sustainability, and I'll end with a short summary. A very brief introduction of MacDermid Alpha. So we are a materials company, so it seems appropriate to start with materials because usually when you develop a new product and you start manufacturing, you start with a material. So MacDermid Alpha provides materials to the electronics industry as well as to industries such as the offshore industry, but also plating on plastic and zinc plating, anti-corrosion, etc., etc. For the electronics industry, we engineer and manufacture plating, joining, and protecting materials. So let's move closer to the materials we have represented in circuits. By the way, on the call also is Claudio. So Claudio and myself, we represent MacDermid within the consortium. So we have 3 separate technologies in circuits. One of them is direct metallization. Direct metallization is a chemical process which is used in PCB fabrication. It replaces electroless copper for plating through hole. So after drilling through holes in the PCB, you need to connect the various copper layers. And the incumbent technology there is electroless copper. Now, electroless copper is a very long process, which means it has various baths. It contains formaldehyde, EDTA, and cyanide, which are quite hazardous materials, as well as palladium, which is a very expensive element. So we have not really a new technology, a technology based on carbon, which is called direct metallization. And it uses no hazardous materials. It uses carbon to make the holes conductive, so you can plate copper through the holes, making it conductive again. So it eliminates the use of the aforementioned hazardous materials. Second technology we have is called ultra low temp solder. And this technology enables the lowering of the soldering temperature to below 150 degrees C. And with that, you can use substrate materials such as PET and PEN, which will be presented later on by Traxon for flexible circuits. And last on the list, and that is the technology I want to focus on today, is low temp solder. Low temp solder is something which was introduced. Let me go to the next one. Was introduced over 20 years ago. So next year will be 20 years ago that there was a ban on the use of lead for soldering in electronics. And you can see here the tin lead solder liquidus. So this is the melting temperature of the alloy at 183 degrees C. That meant we had a soldering range between 205 and 215 degrees C for soldering. And the alternative when the ban on lead came was a SEC 305 alloy, and this is a tin silver copper alloy. But because of the copper in there, the temperature, liquidus temperature, was quite higher compared to the lead alloy being at 217 degrees C. So that meant we had to increase the reflow temperature. With the increase of the reflow temperature, there came a strain on both the PCB as well as on the package, and that introduced the risk of warping. And warping causes various soldering defects such as non-wet open, solder bridging. You can see them here, head and pillow. I'm not going to explain everything of these defects. That will be too long. But to overcome this, we worked on new alloy technologies. So we, as the industry, the suppliers of solder material. And the alternative we came with was a tin bismuth alloy. So that was the first generation of lead-free low temp solder alloys. It has a liquidus of 139 degrees C, so you could reflow at 175 to 215 degrees C. The downside of using tin bismuth alloys is bismuth is notoriously brittle. So that meant if you solder a BGA package on a PCB and you do a drop shock test, the BGA will just drop off, and that hindered the introduction of low temp solder in various types of industries. The mobile industry is one, and of course all applications where you have vibration could not use low temp solder. So we, as the industry of tin suppliers, of solder suppliers, went into looking how to overcome this brittleness. And we came up with a solution of doping. And doping is a technology where you add elements to an alloy, and these additions are below 1%. But it's just enough to reduce the brittleness. So currently we are at what we refer to as HRL3, which is high reliability low temp, HRL, and 3 is the third iteration. And these additives can be copper, it's usually silver, and there could be other additions to it, but this is proprietary. Solidus of this alloy is 138, liquidus is 139 degrees C. For this typical one is 146. So that means you can reflow between 175 degrees and 200 degrees C. So you will reduce the reflow temperature below 200 degrees C, reducing the risk of non-wet opens and non-contacts and what have you. Stellantis did an extensive analysis of the reliability of this alloy for the consortium, and this is typically done for automotive applications. And the conclusion of those analysis is that it functions very well, but not, of course, for the high temp application. So you can think of under the hood, transmission, electronics, chassis, etc., everything which sees elevated temperatures. That really is not the space where low temp solder can be used for obvious reasons. We as MacDermid Alpha did extensive testing also of the reduction in CO2 emissions. So we ran tests. We created a very extensive calculation model in Excel, where we compared low temp solder alloys to SEC 305, and we used these reflow profiles, solder profiles if you like. This one, low temp solder, has a peak at 190, whereas the SEC 305 has a peak of 145 degrees C. Within this calculation model, we also take into account the use of fossil fuels for generating the electricity for the reflow ovens. So we have a portion which is gas-powered electricity production, there's coal-powered, etc., etc. That all has been input in this for this calculation model. And then we took what was typically standard at our customer, how the equipment was run. So in this, you can see here, it's an 8-hour shift, 6 days a week, 50 weeks a year. And the annual Scope 2 emissions, and Scope 2 is something introduced by EPA. It's a direct emission reduction in manufacturing. And the reduction of emissions will be reduced by 13,500 kilograms of CO2 equivalent. So that is the comparison of SAC 305 with low temp solder run at 190 degrees C. You can see here the difference in power consumed, and you can see here the difference in CO2 equivalence reduction per year. So low temp solder and sustainability. It helps manufacturers meet some stringent criteria for eco-labels. Energy Star, EPAT, TCR, just some examples. In corporate sustainability, low temp solder is something which helps, of course, to reduce the energy consumed. It helps reducing emission. Not only that, it also helps with the longevity of solder equipment. The hotter you run solder equipment, the more strain it puts on the equipment, so the shorter the lifespan of these ovens are. So that also helps when you switch to low temp solder. So in summary, low temp solder represents a viable and impactful strategy to reduce the environmental footprint. It also facilitates in disassembly, because if you use a lower temperature when desoldering components, it's less of a strain to the semiconductor, which we want to retrieve, which is also part of the Circ-uits consortium. For automotive, low temp can be a solution, but mainly for interior applications. As, like I explained before, some applications see elevated temperatures for which low temp solder is really not a solution.
Thank you for watching this webinar episode. If you're as passionate about sustainability and innovation as we are, here's how you can get involved. Stay connected with us on our social media and website for the latest updates and insights from the Circ-uits project. Whether you're an individual or an organization, there are plenty of ways to contribute. Reach out to us to learn more about partnership opportunities, events, and initiatives.